So which diene and dienophile could be used in the synthesis of the following Diels Alder products? So before you attempt this problem, please make sure you watch the video that is in the description here about how to number the diene and the dienophile when you are forming the product, so that you can understand how to deduce the reactants if the product structure is given. Okay. So that being said, let's go here, and as we know, the Diels Alder reaction is going to work really well if the diene has electron donating groups and the dienophile has electron withdrawing groups in them. So since the cyano is a electron withdrawing group, this is the part that has the dienophile, and therefore the diene 4 carbon structure is going to be that, and the dienophile is going to be these 2 carbon atoms. And since you already have a double bond in the product, that means the original reactant on the dienophile structure should be a alkyne, because you are going to break one of the pi bonds to make the product in the dienophile. That means the dienophile should be an alkyne like that, and the diene is going to be your simple butadiene. So that is A and that is B. So these 2 combination will give you the product. A and B are that they now have a single bond, which means you should be having a double bond, and since this is a cis geometry, these 2 carbonyl groups are on the same side. That means you should be having a cis alkene in your reactant. If one of these was in the ender position, the other one in the exer position, then you'll be having a trans dienophile. And the other reactant is going to be your furan. So 1, 2, 3, 4, 5th position being an oxygen. So 1, 2, 3, 4, A and B, like that. Same approach can be done here, but as you can notice, the carbonyl here and the cyano here, they are trans to each other. If you look at that through that angle, you will see that the cyano and the carbonyl or the hydrogens are on the opposite side. Therefore this should be a trans alkene dienophile, and the diene is going to be your cyclopentadiene, because 1, 2, 3, 4, 5, that is your diene. And finally here we can see the 6-membered ring, which is a 6-membered ring that you form. Okay, that means the double bond is on this side, which means this is part of the diene. Therefore again it's going to be 5 there, and this is going to be carbon atom A and carbon atom B. Therefore this is a reaction between the 2 cyclopentadienes, and we can draw it in a way that makes it easier to understand. That is your cyclopentadiene, which can act as the diene, and this is the cyclopentadiene, which can act as the dienophile 4, and this is A and this is B. So the bond is made between those atoms.